Hello friends, welcome back to our YouTube channel Open Geology. My name is Gopalji Gupta and in this video I am going to talk about few important questions from CSIR Net June 2024 and these questions can be asked and few of them are also asked in the multiple times. So let us see first question. It is asking about which of the following is the correct sequence of products of increasing weathering of orthoclase. So when orthoclase undergoes weathering, a lot of minerals will be produced. So it is asking about the correct sequence. So these are your options, but in this time it can ask about some other minerals. So let us see few minerals and their sequences. In this column you can see few minerals are there: albite, orthoclase, muscovite, biotite, and hornblende. And here are the secondary minerals which are produced. If we have the weak to moderate leaching, these minerals will form. Further increase in the weathering, then these will form, and very intense weathering, then this will form. In the case of if we have the albite as parent mineral, the correct sequence would be smectite, kaolinite, and gibbsite. And in case of orthoclase that is asked in our question, the correct sequence will be illite, kaolinite, and gibbsite. For muscovite, the same sequence illite, kaolinite, gibbsite. But if we have biotite, then sequence would be vermiculite, goethite kaolinite, or gibbsite. In case of hornblende, the sequence will be smectite, goethite kaolinite, and the final is gibbsite. So you can see gibbsite is in all of them. That means wherever very intense leaching is there, gibbsite will definitely form. Okay, so it can be one more other questions. Question can be like, which of the following clay mineral can be found in very intense leaching? So gibbsite would be the right answer. And these are the sequences. So as per our question, the fourth option, illite, kaolinite, gibbsite, is the sequence for orthoclase. Okay. Let us go to our next question. That is, so it is about the epicenter and focus. Okay. The question is compared to the epicenter of shallow focus earthquake, the epicenter of a deep focus earthquake will be. This is a little bit tricky question. Even if you know, you can get confused. So keep in mind that focus changes, but epicenter is always at the surface. Okay, as you know that earthquake is whether it is here, 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 but epicenter is just the perpendicular point from this focus. So epicenter will always be at 0 kilometer from the earth surface. Okay, that means the correct answer would be at the same level, whether it is shallow focus earthquake, intermediate focus earthquake, or deep focus earthquake. The level would be same for every epicenter. Okay, let's go for the next question. For an earthquake, it is asking about the magnitude and intensity, how they changes from the epicenter. So what is magnitude? Magnitude is the amount of energy that is released during earthquake, while the intensity is the ground motion. Okay, now obviously, let's say there is an earthquake of 5 magnitude, so the energy released will be fixed. Okay, let's say x amount of energy is released. So whether you are from 10 kilometer away from this focus or you are 100 kilometer away from this focus, energy is energy. It will not change. Energy is released, that is fixed. Now if we see the ground motion, yes, the ground motion will change. Let's say this is our focus point. If you are close to focus, there will be high ground motion. As you go away from the focus, ground motion will decreases. Okay, so the correct option would be third. The magnitude remains unchanged and intensity decreases with epicentral distance. Okay, So magnitude for a particular earthquake is fixed. Okay, let's go for another question. Which one of the following is the slowest hill slope process? So this is about the mass wasting topic. Okay, so you all know the very famous the table where if you go upward, the speed increases. Okay, the speed increases, and as we go from right to left, the amount of water will increase. So let's say the highest speed and the maximum amount of water, we call it the mud flow, and the lowest in speed and the lowest in water, we have the creep. Okay, so the question is asking about the slowest hill slope processes. So we can see the speed is increasing upward, that means the slowest are solifluction and creep. Let's see, there is solifluction in the option, fourth option will be our correct answer. So multiple times questions has been asked. Sometimes they can ask about the arrange them in the order of speed. So this question is also asked, I think, in gate, and yes, definitely it is already asked in net also. CSIR net. Okay, so this table is one of the important. Then water having total dissolved solid TDS in the range of 10 to the power 3 to 4 milligram per liter, it is classified as. So this is the simple water classification. Here is the table. If we have TDS of 0 to 1000, we call it the fresh water. 1000 to 10,000, we call it brackish water. So here 10 to the power 3 to 4 will comes under the brackish water. Now 10,000 to 1 lakh we call salty or saline water. If more than 1 lakh TDS, we call it a prime. Now one important thing here to note is, in question it is written in milligram per liter, but in the table I have mentioned it in the form of ppm. This is nothing but 1 ppm is equal to 1 milligram per liter. Okay, so you can also see this question as a unit conversion. Let's say you are doing some numerical and you got answer in milligram per liter, but options are in the form of ppm. So simply 1 milligram per liter is equal to 1 ppm. Okay, I hope you like these questions. We will do few more questions in the coming days. All the slides of this PPT will be shared on Telegram channel Open Geology. You can simply search in the search box Open Geology. You will get this channel. Okay. Thank you so much. We'll see you in next video.